Neptune boasts winds that scream at over 1,200 miles per hour, faster than the speed of sound on Earth. How can a planet so far from the Sun generate such extreme weather? Today, we'll unravel the mystery of Neptune's supersonic winds, exploring the unique factors that contribute to this planetary phenomenon and why it defies initial expectations. Understanding Neptune's winds offers insights into the complex dynamics of gas giants and the limits of atmospheric physics. The first key is Neptune's internal heat. Unlike Earth, which primarily receives energy from the Sun, Neptune radiates significantly more heat than it receives. This internal heat source, likely leftover from its formation, drives powerful convection currents within the planet's atmosphere. Think of it like boiling water: hot material rises, cooler material sinks, creating a constant churning motion. This churning is the engine behind Neptune's winds, providing the initial energy. Now, let's talk about Neptune's composition. It's primarily hydrogen and helium, like Jupiter and Saturn, but with a higher proportion of ices, water, ammonia, and methane. These ices condense into clouds at different altitudes, creating distinct layers within the atmosphere. These layers don't mix easily, leading to what's called a differential rotation. The upper atmosphere spins much faster than the deeper layers, creating a shear effect, like two conveyor belts moving at different speeds, which amplifies the winds. Here's the surprising part: Neptune is the furthest planet from the Sun, receiving very little solar energy. You'd expect weaker winds, right? Yet, Neptune's winds are the fastest in the solar system. This demonstrates that solar energy isn't the primary driver. The internal heat and differential rotation are far more significant. And speaking of rotation, we'll delve into how Neptune's rapid spin further intensifies these winds in just a moment. Neptune's rapid rotation plays a crucial role. The planet completes a rotation in just 16 hours, which, combined with the Coriolis effect, dramatically deflects the winds. This deflection creates powerful eastward jets, accelerating the air to those incredible speeds. It's similar to how a spinning ice skater pulls their arms in to spin faster. Neptune's rotation concentrates and accelerates the atmospheric flow. We've explored Neptune's internal heat, its layered atmosphere, and its rapid rotation. But what about those mysterious dark spots, like the Great Dark Spot observed by Voyager 2? We'll uncover the connection between these transient storms and the planet's overall wind patterns next. So, to recap, Neptune's supersonic winds are a result of a unique combination of factors. Internal heat provides the energy, a layered atmosphere